Title of this lecture is The Muscular System. This is the first of several lectures in this series. Now, from our work yesterday, we learned that the muscular system has two main jobs. What were those?
Energy and heat.
Yes, movement and heat. The muscular system is responsible for, and I'll put those down. Textbook and the online text identify 5 different things, but for number 1 and 2. And if I had to put them in order, I would choose these 2 here. Produce skeletal movement. And the second one is thermoregulation. And this word right here is just a fancy way of saying regulating heat. Well, the muscular system may do a little bit of regulation. Really, it's primarily heat production, but that does definitely contribute to the body's ability to thermoregulate. In fact, that all the heat that keeps our body at that toasty 98.6 degrees Fahrenheit is because our muscles just create a tremendous amount of heat through their metabolic processes. And if ever you're using your muscles a lot, they make even more heat, which is why when we exercise, we have to sweat to accommodate that unless it's really cold outside. The next one I've got on the list here of the functions, and this one's weird and kind of gross. Guard, this is word for word from the text, entrances and exits. What? Yeah. In other words, sphincters.
What?
Yeah. Sphincters are round muscles that basically either open or close to either permit or prohibit things from passing. I say sphincters. Most of the time people think of the anal sphincters. They think, oh, sphincter is the same thing as a butt. Well, there are sphincters there, but those are only 2 of 6 you have just in your digestive system.
Don't we have them in our throat?
Yeah, there's 2 in the esophagus, upper and lower esophageal sphincters. There's one at the end of your stomach, so food stays in your stomach long enough to be digested. It's called the pyloric sphincter, and then after digestion in your stomach's occurred, that sphincter opens up and allows things to pass to the small intestines. Then things go through the small intestines, and there's another sphincter at the end of those called the ileocecal valve that keeps things from passing into the large intestine before it's time. So that's a function of the muscular system too, because we couldn't have sphincters without muscles.
Our bodies are just so smart.
They're really, really well put together.
Like, we don't even have to tell them what to do; they just do it.
Yeah. Right now, think about if you had to actually give a voice command for everything. Digest food. Beat. Take a nap. Dead. Yeah. That's not an onomatopoeia. That's dead. All right. The next one, support soft tissue. This one is, what I mean by that is it protects your organs. It's clear, your rib cage does a good job of protecting your heart and lungs like that. But underneath that is really just a muscle tube that holds everything in. Where your abdomen is, the only bones in that area at all are your lumbar vertebrae. And they're just this stack of hockey pucks in the back. Everything that's keeping your organs in is basically your abdominal muscles. Rectus abdominis, transversus, your external obliques, they're all kind of holding that in place. So supporting soft tissue. And the last one you're working on right now, most of you, is maintaining posture.
Most of you.
Well, if you're asleep on your desk, then not so much, but looks like everyone's holding it up in some way. Maintaining posture.
It'd be cool to just you were able to make your body just go limp. That way you just turn into a puddle. That way you
Ooh.
just, scoot under something.
Like to make your bones disappear?
Like just to make them really rubbery so you can conquer almost anything.
I could see where that might backfire,
Octopus.
but yeah, it'd be neat. It'd be neat. All right. Okay, I put this weird line here because I need to throw something in the middle of this mix, and I'm going to come back to it, and that's about joints. Joints are otherwise known as articulations, which, if you think about it, and I like this word articulation, and I'll sidebar here. If you see the prefix art, arth, or arthro, it means joint. In fact, there is a category of that includes in the taxonomic phyla that includes everything from crustaceans to spiders and insects. It's called phylum Arthropoda, which means jointed foot. Articulations, art or arthro means joints. I find this to be interesting though, because a joint is really a connection between two bones. Connection, okay, watch this. If someone is good at articulating, what are they doing? They're speaking. They're articulating. They're forming a connection between themselves and another human being by the way that they're able to form their words, articulating. Yeah, just found that interesting. Okay, 3 classifications of joints. And this is based on how they move or if they move. First one is called synarthrosis. Synarthrosis are types of joints that are immovable or fibrous. They don't move at all. Why in the world would you want a joint that doesn't move at all? Can you name a place in the body where it might benefit? 2 bones come together and can't move.
Your skull.
Great example. Example is sutures in the skull. We don't want those to move.
Mr. Lee, is there any way you can like zoom in some of the paper because I can't read?
You can move up here. Once I start recording, I can't change the size of it.
Okay.
Yeah, sorry about that. Otherwise, I wouldn't mind to. Yeah, it doesn't let me zoom once I start recording. It's like, no.
That's fine.
Okay, the next one is sort of in between, and it's called amphiarthrosis. And this is a slightly movable joint. Which is kind of confusing. What is it that constitutes slightly movable versus immovable? It's kind of a range. Let me give you one example. Example, what is that place called where the 2 pubic bones come together? It's right next to that. Pubic starts with an S. Symphysis. Pubic symphysis is a ligament that connects the 2 pubic bones together. It affords just a small amount of movement, but not too much. In fact, if it is too freely movable here, it actually causes alignment problems with the hip. Now, at a certain time of pregnancy, the body will actually release a hormone, which its name almost sounds made up. It's called relaxin. Relax and then IN at the end. It's a hormone that causes the pubic symphysis to actually relax slightly, so that that to help with the childbirth process. Now, the last one, most important for what we're talking about, is a joint called diarthrosis. diarthrosis are freely movable joints. Example is everything else pretty much. Give me an example of a freely movable joint. What do you got? All right, no one gets to move any of their joints until you name one. Elbow, there we go. Now you're all free. Elbow, jaw.
Mandible.
Mm-hmm.
I told them they couldn't move, they had to move their...
I just created a situation you couldn't get out of. Well played, Drake. Yes. Nobody. Oh. Even and then you have to move your tongue. All right, yeah. Pretty much everything else that moves here, shoulder, fingers, okay? Any other freely movable joint is considered diarthritic, okay? These are also known as synovial joints. Diarthritic joints are synovial joints. They're called that. They have a particular type of fluid called synovial fluid that lubricates them. Now, let me talk about some types of these types. And these types, and if I give you one, you'll probably know a few others. Ball and socket. Then we have our elbows and knees, which are hinge joints. Hinge. There's another one called saddle. Another one called pivot. And there's a few others like that too, but there are several types of those. So, ellipsoidal is one. There's a few others too. Okay. Little sidebar on synovial joints. Synovial joints are lubricated with synovial fluid. With synovial fluid. Now the neat thing about synovial fluid and synovial joints, physics students, you'd appreciate this. It is the slickest substance in the known universe. It has the lowest coefficient of friction of anything known. Now the weird thing about coefficient of friction is they don't have a unit. Synovial joint, friction. Let me find one. Give me a second. Sorry, viewers at home. Well, okay. Nope, can't find it. All right. As far as movement goes, all right. Some examples for friction. Rubber on concrete, okay? A lot of friction, right? Otherwise they wouldn't make tires out of the stuff. Its friction is 1, okay? And I'd love to give you a unit, but there are no units for this, okay? Ice on ice. If they're both moving, the friction between ice and ice, if they're both moving, is 0.03. Very, very low. Friction of a synovial joint, if it's healthy, 0.003. It's 10 times slicker than ice on ice. Okay? So this is really, really slick if it's working correctly. Now, as we age, as arthritis causes joints to swell, as our cartilage breaks down at the end of the joints, then that friction will increase, and it's not good because it causes stuff to break down faster. Okay, synovial fluid. They are encapsulated. They're encapsulated or sealed in a ligament membrane known as a joint capsule. In a ligament membrane known as a joint capsule. Okay. And they're all sealed in here. I think I did find a picture of that, sort of, by not looking.
So everything that has bones, do they have this?
Yes. Yes. So like even a chicken leg, you know, if you're before it's cooked, if you look at like a chicken leg quarter with the legs attached to the thigh, well, what's called the leg of a chicken is actually its tibia and fibula, and then the thigh is actually its femur. It's got a lot of meat surrounding it, but the two where they're connected, you'll see this same setup here. They have cartilage in their joints. Wow, that's really bright. Okay, I'm gonna tilt it at an angle to avoid the brightness here. But you've got this joint capsule here that surrounds the outside, and then in between the two is fluid that's continually produced and lubricating, so those joints don't have a lot of friction between them. But it's all sealed in this joint capsule. Okay.
So why don't they like try to extract that stuff and like put it somewhere else?
It wouldn't work the same. You mean like to use it for like motor oil or something?
No, like say like somebody like say something's not right with somebody's joints and they don't have enough that like could maybe take it from like an animal somewhere else and put it in there.
It has less to do with their production of the fluid and more to do with the breakdown of the surfaces. Because the reason synovial fluid is so slick is it works in conjunction with the cartilage, because the cartilage is really slick. And if you've ever felt like I don't know if you're, this is gross, but like you ever taken a chicken quarter and like broken it apart and felt at the end of those bones they're super slick because they're covered in cartilage. I know that's gross, but try it sometime. That because the cartilage is so slick, that synovial fluid works together with that cartilage. Where the breakdown is that cartilage starts to wear off and it doesn't heal very fast because there's not a whole lot of blood vessels in cartilage. And then you have bone grinding against bone, and you could dump gallons of synovial fluid and it's not going to help that situation. So I don't know that there's really ever, and there probably is, just because there's so many people on the earth, a condition where people aren't producing synovial fluid as much as there's damage to the joint itself causing them not to work as efficiently. It's a good question, though. All right. These here require skeletal muscle to move. If you don't have skeletal muscle, all the joints in the world don't have any purpose. They're not going to be able to really do anything effectively. So there's our little sidebar into joints. I've sealed that back in like a joint capsule. And now we can move forward with the muscle. Now, number 3 on your sheet yesterday, or your online sheet, muscle is known as blank tissue because it must get shorter. Do you remember what that was? That is a description of its structure for sure, because there's these stripes that go through it. And it was kind of a reach for me to get you to come up with this word. I apologize. I didn't know how to ask this one. It's known as contractile. Because it must get shorter to work. Contractile tissue, like a ratchet strap. It has to get shorter in order to work. As such, muscles cannot push. They can only pull. So back to the question I asked in the primer yesterday. How can I do a push-up if my muscles can only pull? What muscles are working if I'm doing a push-up? Triceps is one of them. And your pecs. What happens is if I'm pushing, okay, the triceps on the back of my arm are pulling and getting tighter and straightening out my arm. My pectoralis muscle on my chest is shortening and bringing the humerus bone back in toward the center again. So even when I'm pushing, my muscles are pulling. Therefore, all muscles must attach at least, oh, I hate that I wrote at. To at least. Now it's going to be to at least 2. Awesome. 2 points. So if something is going to pull, it has to be attached to 2 different points to be effective with what it does. And these points have specific names, and we're almost done, gang. They're called the origin and the insertion. Origin and the insertion. The origin, what do you think that is? Why is it called the origin?
Isn't it like the middle?
Not quite. Strangely, the middle of a muscle, this doesn't sound very scientific. It's called the belly of the muscle. Yeah. These are both where they connect. No, you're fine. You're fine.
Where the muscle does the work?
It's where it anchors. What did you say, Alex?
Beginning?
Yeah, it is the beginning. Okay, this is the beginning. We go like, how do you define the beginning of a muscle? Here's how. This is the attachment to a non-moving bone. The attachment to, and if you want to think of it this way, to the anchor point. Because if both bones moved, that would be really bad. You're not really being effective there. We want one to hold its position and the other one to cause the movement. Then the insertion would logically have to be what? Your brain is looking for a completed statement here. Attachment to what? Yeah, to the moving bone. Okay, I'm going to oversimplify here. Okay, here's the bicep. Bicep has two heads, which is why it's called a bicep. It attaches way up here to the coracoid process of the scapula. It attaches here to the humerus. And then down here below, it attaches to the radial tuberosity of the radius. So as this gets shorter, it brings the arm up. So its origin is here because these bones don't move when you move your bicep. But the radius does, therefore it is the insertion because it's the one that's moving. The last thing we're going to write in our notes today is this. The motion that is perpetuated by the muscle, and that's what we're going to look at tomorrow, is the action. All muscles. How many muscles are in the body?
600.
Yeah, 600 and change. No one's really willing to commit to exactly how many muscles. I see some that said 620, some said 640. There's a bunch of them. Okay, and some argue, or whether or not this is one muscle or two, and things like that. But they all have an origin, all have an insertion, and all have an action. And action is simply the motion perpetuated by a muscle. Or what does it do, basically? What in the world does that muscle do? Okay. And it's largely ruled by what type of joint does it cross. If it crosses a ball and socket joint, it's going to do adduction and abduction. If it Across the hinge joint, it's going to be flexion and extension, things like that. So we're going to get into more detail on actions as I give you a few examples of muscles in our next lecture tomorrow.